Good morning, colleague. Today we are going to solve exercise 318 from the book Fundamentals of Electrical Circuits of 6. In this exercise we are asked to determine the voltages of the nodes in the circuit by applying nodal analysis. They ask me for the voltage at point 1, at point 2 and at point 3 using nodes. Well, the first thing I always recommend is to identify the flow of currents in a circuit. Do a visual analysis, and based on that direction of the currents we can apply node analysis. For example, I'm going to stop at this 5 amp current source, which makes it easier for me to determine the direction from here. Well, everyone can do it however they like, but I am going to stop here for the following reason. This is a current source that enters here at this point and has to take its path in different directions. And I can say that one of them is to the left, that is, and the other is to the right towards here. In other words, at that point that enters here, it is divided to make a batch to the left and another batch to the right. When this current arrives, first check here. Right now I'll give you names. They reach this point, there you have to take direction in another direction. The first one that comes to mind is towards this, downwards, since we are in the direction of mass, and on this side, it also grabs downwards, towards the same direction of mass. Good. Another thing we have to notice is this source of tension that is connected between point 1 and point 3. It is a voltage source. It is a voltage source connected between two nodes. That's super. It is a super node. It means that this entire point, which is this one, can be taken as a single point. Okay, now what I'm going to do is, I'm going to start doing the analysis for the node. Let's remember how this source is here, because we have to take it as if it were a point, right? That is, as if there were no voltage source, that is, as if there were a short circuit here. Therefore, we have to start from the currents that enter and leave also at that point. So I'm going to put analytics on node 1. And I'm going to say that all the current sources, that all the currents don't count. All the currents that enter at that point are going to be equal to those that leave. Remember that this point is the same as the one here, right? It is a common node. Therefore, I also have to take into account what goes in and out here in point and point 3. It is the same point because of this source of tension. So all the currents that enter this point, which is practically the same, will be this one here. Well, I'm going to name the currents. I'm going to call it current I1, current I2. The name can be whatever you like. I took it from left to right, current I3 and current I4. So at this point the current I2 is going to enter, which is this. It's going to come in at this point. What is all this? The current N2 I am going to put here, the current N2, and the other current that is going to enter this point, which is the same one that is here, is the current N3 is going to enter the same node plus the current N3, right, as all that goes into all of this. This is as if it were a common point, right? It's like it's all of this. I am saying that this voltage source for the first analysis is a short circuit. Well, now I have marked the currents that came in, the En2 and the Y3. Now it's my turn that has to be equal to the currents that come out. The first current I see coming out of that whole node that I already pointed out or already pulled identified anyway. It is the current M1 says it comes out. It comes out from that point. Plus the current N4 that also comes out. Ready. Now, since I already have the current flow, all I have to do is replace them with voltages and resistances. The first one that I have to replace with I2, the one that comes here, because it is going to be the node V2, is the node 2 for a voltage V2 minus the node V1 is less because It is less because if the current goes there, it means that this voltage is greater than this one. That is why this one is positive and this one is negative, because a voltage was taken here, because it is creating a force in opposition to I2, but I2 wins because the current is going to be about the resistance of UFOs and all that is the I2. Plus the current I3, which is the one that comes here. The same would be V2. V2 minus C3. All this about that. About 2 ohm. It will be equal to the current I1. The current that I put here is 1 out of 4. Only 1 out of 4. Because this point is the Earth, it would be 0. There is no voltage plus current and 4, which would be V3 over 8. Okay, so I'm going to apply now. I have V2 here. B2 about 2V12 more B2 over 2 minus V3 over 2 and 1 over 4 plus V3. I advise you to watch the video to solve it and then see what the result would look like. So I'm going to operate the variables that have V1 this well. First I'm going to pass everything to the other side of the equal. Then it would be V2. I'm going to do it here V 2 over 2 minus B1 B2 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 3 over 2 minus V14 minus 3 over 8 is going to be these two on the other side the same. That's why the equal sign changes. I'm going to operate everything. What would this be? Would this be it, So minus 1 middle, minus 1/4. That gives me minus 3/4 of V1. Now whatever has V2, which would be 1/2 more, 1/2 and there is no more, it would be 1 volt 2. V3 minus 1 middle minus 1/8. Well, they would be minus 5/8 of 3. All that equals 0, eh? Notice that if I multiply by 8 I eliminate the denominators, because it is greater, and when I multiply by 8 then I would not have any denominator left, which is something I can do, or I can leave it like that, but if I multiply it by 8a, this is optional, it suits me like. And it would be 8 and 142 times 366 and 1 plus 8 V2 minus 5 P3 equals 0. And this would be my first equation. Now what I'm going to do is I'm going to delete all of this. And I'm going to rewrite that equation up here, or I'm going to put it here. Minus 6 V1 plus 8 P2 plus 8 volt minus 5 V3 equal to 0. This is my first axis. And now I'm going to apply the one that is here, which is practically occupying the 1 and the new 3. Now I am going to apply node 2 to point 2. It has equal nodes. The currents that enter point 2 are equal, the currents that leave. So what comes in here is going to be, I marked it as 5 amps, and remember that this 5 is going to be equal to what comes out. He had told me that, and 2 more and 3. You set the direction as you think. You are trying to have common sense regarding the polarities of the system, and when we mark the direction of the currents, remember that we have to leave them as they are every time we work on them. I didn't accidentally delete 44. Well, then this would be the current that enters 5 is going to be equal to those that leave 2 and 3. So substituting 5 would be equal to 42, which would be the voltage. 2 minus tension 1. All this on 2 plus the 43, that would be the tension. 2 minus the voltage 3 over 2. And applying to the 2 I'm going to have, that would be 5 equal AV2 over 2 V1 over 2 to pi 2 and 2 minus V3 over 2. Well, let's go here. What I'm going to do is good. First the V1. I think it's this one. I am only going to divide this here so as not to confuse with this part. I'm going to put minus V1 over 2 volts 2. I have 2. I have a half and a half. Well, it would be plus V2 and V3 would be minus V3 over 2 is equal to 5. Okay, now notice that I can multiply by 2, and if I multiply by 2 to eliminate the denominators, the equation closest to this I can leave it like this, but I'm going to multiply it by 5. It's okay. Multiply by 5 on this side. I have to multiply by 5 on this other side of the same. It's going to be like minus V1 plus 2 V2 V3 equals 10 10 10. 10 ready. I already have my second equation that I'm going to put here, minus P1 plus P2 minus B3 equals 10. They are both. We know that whenever there is a super node A, automatically A, there are only two equations left, right? Because whenever there is a super good, we grab more than one node, we are grabbing 1 and 3 at once. So this causes us to always be missing a variable, because here we have two equations with 3 unknowns. To solve this system we need another equation where we can take it. Applying the principle of the voltage law that I can. I have to look. Take this point, this super node. A loop analysis explains. I know that between point 1 and more, that is this point exists the tension that is V1 F1, and between this point and this point, this is the tension that B3. I can replace all that is here with those tensions, right? So I can say that instead of suddenly I am going to place there at that point the representation of that tension V1, which would be this, and on this side the representation of that tension, which would be this B. So at this point V1 is connected to this source of 10 volts that would be minus more. I would be 10 volt. And we close here on this common point. Now, why do you say that? Because the voltage law says that any voltage in a loop is equal to 0. It doesn't matter if you take this loop that is here or take this one that is here, or take this complete one that is here. That is, the voltage drop here also has to be 0. Or if I take the loop that is here, well, the sum of the tensions of a loop is equal to 0. That's why the only thing I did was make this loop. That is, it would be the voltage V1 with plus minus polarity. Why more? Because I set the polarity more up and less down because of the direction of the current. If the current comes, it goes, it polarizes more, less, and since I took the current here downwards, it would also be more less. If I had turned the current up, it would be less up and more down. Well, now what I have left is to do the analysis. The LVK here tells me that it would be minus V1, minus 10, more than 3 to 0. Then I organize it. That's it, and I have my next equation that I'm going to put here, which would be V1 plus 0 volts at B2 plus B3. Maybe this is here in negative. I'm going to pass it to the other one equal to 10. So I already have here what would be our third equation minus B103, right? Okay, now I want to solve this thing. I'm going to delete this and I'm going to make use of it. I'm going to use the calculator. The method you use to solve it depends on each person. And to not be so long, I'm going to use this to help. The first equation was this. The equations I'm going to put here would be minus 6 space 8 plus or minus 5 point and 4 minus 1 space. 2 space is not a semicolon, and it would be minus 1 space 0 space 1. Now matrix B is that of what is on the other side, just like it would be 0.10 more. Well, notice that the matrix at minus 6 8 minus 5 would be this minus 6 8 minus 5 minus 1 2 minus 1 minus 1 2 minus 1 and minus 1 0. Well, that's the matrix that's here before the. Just like this is the matrix 0, 10, 10, 0, 10, 10. And this is solution A versus B. So it tells me that the voltage B1 is 10. B2 voltage is 20. Voltage 3 is. I'm going to put voltage 1 here. At point 1 would be 10. Voltage 2 would be 20. And voltage 3 would be 20 again. So that's what we're going to see. The voltages of the nodes in circuit 123 are determined, and these are the voltages. Well, see you in the next video.